For centuries, war has been the mother of invention. From the prehistoric spears of warring tribes to the atomic bomb that ended World War II, the Second World War also gave us this, a fascinating and largely forgotten engineering marvel, the Great Panjandrum.
So what exactly was the Panjandrum? In short, a twin-wheeled, gigantic, rocket-propelled monstrosity developed by the British to get past the German defenses on the beaches of Normandy for the D-Day invasion.
The Great Panjandrum, with its 10-foot-high wheels and explosive payload, was engineered to get past landmines, miles of barbed wire, steel obstacles, and eventually reach a 10-foot-high, 7-foot-thick concrete seawall and blow a hole right through it.
There was only one problem with their design. It never worked. Every single time they tested it, what they hoped would be a straight-ahead beach buster instead became an unpredictable whirling dervish of mayhem. Run, dog, run! Did I mention that it was also packed with explosives? And the Great Panjandrum was abandoned and kicked to the curb. But here's the thing, the simplicity of its design and execution, big wheels to get over big obstacles, is actually kind of brilliant. And I feel like the designers of the Panjandrum might have been a lot closer to success than we think. So, unmitigated failure or under-realized brilliance? That is what I have come to find out. And to begin, I'm going to take a much closer look at what I consider to be the strongest candidate for the Panjandrum's failure. Three, two, one! In unpacking the reasons for the Panjandrum's failure, I love the design, so I am inclined to look towards its execution, towards its propulsion, specifically its rockets. And who better to help me investigate this than a bunch of enthusiasts at the Aeropack Rocketry Club. There it is! These are my kind of people. Here we go, launching in 3, 2, 1, go!
Nice. Nice straight up.
This is not a bad hobby you have.
No, it isn't. It's a lovely hobby.
How high can some of your hobby rockets go?
We had a fellow fly a two-stage home-built rocket to 260,000 feet.
Whoa! These are real rockets. These aren't toy rockets at all.
They're not. They're subscale, small rockets, but they operate on all the same principles as the solid rockets that NASA flies.
I need some help. The two wheels of the Panjandrum were driven by a couple of dozen or more rockets mounted in each wheel. If you've got 20 rockets on one side and 20 rockets on the other, and only 19 of them fire, that's a problem.
Absolutely.
Making sure all the rockets, 32 of them, fire simultaneously strikes me as the biggest problem to solve.
The biggest thing is getting any rocket to light correctly, any solid motor.
Oh, really?
Yeah, that's the hard part.
When solid rocket fuel ignites, slight variances in manufacturing and the chaotic nature of combustion itself can often cause rocket motors of the same specs to behave slightly differently, meaning getting multiple rockets to perform identically at the exact same time is no trivial matter. William and his Aeropack team are the perfect colleagues to help me figure out the Panjandrum's rocket propulsion system and start testing with the real thing.
And this is our Panjandrum.
Well, actually, a smaller 1/10 scale prototype we like to call our Junior Jandrum.
All right. Let's start attaching some rockets.
For our first test, we're going to attach 10 rockets, 5 on each side. That should give us equal balanced propulsion. The critical factor here is simultaneous ignition of all the rocket motors.
Now we wire.
Attention to detail is critical as we wire every connection precisely and hope that each of these igniters goes off at the same time.
I am curious to see if all 10 rockets fire simultaneously, and if they do, will it track straight? That's the behavior I'm going to be looking at for this test.
The test course for our junior Jandrum trial run, just like the beaches at Normandy, we have our strip of sand, obstacles of barbed wire, steel spikes called Czech hedgehogs, and finally, the impregnable seawall, in this case, made out of cardboard boxes, and of course, tiny heroic soldiers.
That looks beautiful.
It does.
All these leads are hooked up to our battery that will fire up our rocket motors and send our mini Panjandrum on its way. We hope.
We are hot. You ready to go?
We're ready to go.
All right. Here's hoping for 10 rockets all at once. In 3, 2, 1. That was beautiful. Oh, it smells like the 4th of July.
It does, all that black powder.
Oh, look, it has burned a track.
Yep, it's all sticky.
Yeah, we literally were burning rubber.
Yeah.
That test yielded some genuine information.
Looking at the high-speed camera footage, we can clearly see that we didn't quite achieve our goal of simultaneous ignition. That rocket right there lagged behind by a fraction of a second, causing our junior Jandrum to veer to the right. Also, it seems that the nearly 75 pounds of combined thrust produced by our 10 rocket motors was a bit too much power for our 7-pound Panjandrum.
I'm kind of inclined to try it at like 60%, like 3 rockets on each side.
We're going to take it down a notch and try to dial in this thrust-to-weight ratio.
3, 2, 1. Here, whoa. And it's doing a pirouette. Let's see if it sticks the landing. Oh, the Russian judge is going to give it a big score for that. Well done, everybody.
Well, at least we replicated one thing from World War II, a magnificent failure. Looking at the high-speed camera shows how close we came to simultaneous ignition. But our rocket placements between the right and left side were out of alignment, causing our junior Jandrum to spin way out of control. It's time for one more test, and to minimize the risk of failure,
I'd like to try 2 rockets, just one on either side. And let's do 2 that are directly in line with each other, so the push is exactly the same. Armed, we are hot. Mini Panjandrum going live in
3, 2, 1.
Yeah. There you go.
All right. It even stayed in the sand for a while. There we go.
well, at least it didn't spin out of control. Those 2 rockets sent our junior Jandrum on a relatively stable, albeit curved, run, proving to me that with some proper tweaks, there might just be merit in this Panjandrum madness.
What's your intuition? Do you think this will work full scale?
I think if we got the mass and the propulsion dynamics correct, then I think it probably would.
That is also my opinion.
Yep.
Awesome, to full scale we go.
Yep.
The small-scale test has shown us 2 key things to be on the lookout for when testing our full-size World War II Panjandrum: simultaneous ignition and balanced propulsion. We also need to dial in our thrust-to-weight ratio, because our next build is going to be 10 times bigger and that much more dangerous if it goes spinning out of control.
As the sun sets on Mare Island, I think that was a really successful day of experimentation. I think this could work. Once we got the power to weight ratio balanced with just 1 rocket on each side, we got a stable moving forward, and that is super, super encouraging. But the second thing I learned from today is I don't think there's anything further we can learn unless we go bigger. We have to go to a full-size Panjandrum, 10 feet tall, 32 rockets, just like they did in World War II. Yeah, right through the seawall it's gonna go. Da-da-da-da-da! Bam! Ho-ho! Hey, that was good. What's different about this shop on location than any other shop I've ever used on location is that I'm filling it with most of my tools, most of my hardware. All of those cases are all of my nuts and bolts and springs and bearings and wire nuts and lugs and heat shrink tubing. It's everything that I have in my mental toolbox. So even though I'm on location, I shouldn't be restricted in my problem-solving ability because I've brought it all with me. This moment, just before starting a brand new build, it's really exciting to me. You have this thing in your head that you're gonna build, and now the shop is clean, and all the materials are assembled, and it's time to take the thing that's in your head and make it real.
The terrible events of World War II tested some of the sharpest engineering minds of both the Allied and Axis powers. But not every innovation was a rousing success. World War II also spawned some notable failures, like a gun designed to shoot around corners, and incendiary bat bombs that burned down a US military airbase during testing. And the Great Panjandrum, a rocket-powered World War II weapon that was deemed a failure at the time, but one I believe was actually a pretty good idea. I love the simplicity of the Panjandrum's design. Basically, big wheels to go over big obstacles. And that's where our build begins, with those gargantuan 10-foot-tall wheels.
Oh! It's always good to start off on the right foot.
Wow, that was my left.
Our vertical tube roller turns our steel parts through a pyramid of metal wheels, requiring several passes to achieve the radius that we need. It takes time.
The man I'm bending steel with here is my colleague John Marcoux, and he's a very seasoned and intuitive builder, and that's vital for an operation like this because bending steel is not as simple as putting it in a rolling machine and just going back and forth. Tiny inconsistencies in the alignment of the wheels and the manufacture of the steel can cause your long pieces of steel to wander all over the place. And both people in this operation need to pay careful attention to that to run it off at the pass and end up with a nice level product.
Let's take it over to the jig, see if it fits.
This wooden jig is a template to get our precise measurements of our wheel and spokes correct and consistent, and to hold the pieces in place. Because our Panjandrum requires 4 separate wheel rims, it's critical that they are all exactly the same. And this lets us replicate them perfectly without having to, reinvent the wheel.
This here, the portable battery-powered bandsaw, one of my favorite tools. All right. Get the thin wheels to make it through a minefield. You got your center payload, a couple thousand pounds of explosives. This is totally a beautiful thing to contemplate. Well, 3/4 of a century after its invention, we have a Panjandrum. And as I'm sitting on this thing, I feel like I'm about 4 years old because its size is so gargantuan. And I can only imagine that the builders of the real Panjandrum felt the same way, like had the same kind of laughter at the simplicity and absurdity of this perfect solution. Big wheels for getting over big obstacles. The only question I have about its functionality are these rockets. Can we get all 32 of these rockets to fire simultaneously? That's the next thing we have to test.
Rocket technology took a giant leap forward in World War II when German military scientists developed the first gyroscopic guidance system capable of guiding their V-1 buzz bombs precisely to their targets. Unfortunately for the designers of the Panjandrum, British engineers never quite got the hang of rocket technology during the war.
So right now, we are gearing up to just do an ignition test. The most complicated part of the original Panjandrum is the rocket ignition system. The difficulty is that there's 32 rockets, which means 32 separate igniters. All of them have to be wired to 2 separate common, one hot, one ground. You've got to get them all to light up simultaneously.
Is it red, black, green, white?
Yes.
The thing about a system like this is that, I mean, we've got 32 rockets, so 32 igniters, 32 wires in blocks, and that's not just 32 points of failure, that's like at least 64 points of failure, because every wire has 2 ends. Oh, no.
This is tedious work, but I also really love it. You don't get good at this kind of work without loving it. I mean, you have to kind of give over to the tedium, to the zen, to that level of concentration required to make sure that you have properly checked everything.
Sometimes the best way to mitigate failure is good old-fashioned attention to detail.
Seems good.
Deal.
Are we almost ready to do a test of these?
Yes, we are.
If it's successful, all 32 of these are gonna catch on fire and show us that we have enough power and our system is correctly wired to ignite 32 rockets.
Here we go, launch test in 3, 2, 1. Happy birthday.
One of my favorite parts, checking the high-speed camera. Now I'm looking here to make sure that ignition is as close as possible on all 32 initiators. Oh, wow, what a fireworks show! From the first to the last initiator, not more than 150 milliseconds elapsed. That is about 1/8 of a second, and that is totally within the realm of simultaneity that I was looking for. Yes, simultaneity is a word.
We're just gonna do a single motor ignition test here just to make sure that they fire. I wanna see what it does.
It's time to talk about the rockets, which are powering our Panjandrum. They're called H motors, and in our research, they're the closest analog we could find to the original rockets that powered it.
Well, it's definitely not kicking that igniter out. Here we go. Rocket motor test. Just touch it to a battery. In 3, 2, 1. All right. That was beautiful.
Smells good.
Smells like 4th of July.
Looking at the old footage of the Panjandrum, my eyes tell me that the primary culprit in most of the failures was likely a failure of simultaneity. Hopefully, that's at least one potential problem we can check off our list. But this was just a bench test. It's time to take our Panjandrum out to the field and fire this sucker off for real.
It's P-Day. It is time to finally light up our Panjandrum in this beautiful grassy flat field on the Pacific coast about 50 miles south of San Francisco is the perfect location for our launch. Now, we have replicated in every way our Panjandrum to match the original. 10-foot diameter wheels, 6 feet apart, 32 rockets powering them.
And the real one would have had thousands of pounds of TNT in the middle.
It has the igniter
Already in, so that comes out like
already good
this.
to go.
The 32 rockets we're using to power this Panjandrum are the best analog we could find for the original rockets, and they're called H motors.
Time to install some actual rockets.
When ignited simultaneously, these H motors should provide roughly 300 pounds of thrust and hopefully propel our Panjandrum forward at about 20 miles per hour. As we learned in our small-scale tests, simultaneous ignition and balanced power on each wheel is critical.
Every single failure I can see in the footage of those British beaches shows rockets misfiring or misbalanced panjandrums where a bunch of rockets are firing on this side and not the same amount on that side.
The logistics of this puppy are starting to really sink into me. 32 rockets, 32 fuses, landing crafts crossing the English Channel full of soldiers, sea spray. Just getting this candle to light on time would have been a logistical nightmare. These are the last two. 64 separate connections, 32 rockets, 300 pounds of starting force. Let's light this candle. There it is.
Good, good. Okay, strap is free. Let's run the wires in the quick release.
Okay. Doing a final eyeball check. All these connections look good. I'm kind of curious about what it's gonna do. Is it gonna just fire right into the Pacific Ocean? Is it gonna turn into a spinning top of death that kills us all? Or more astonishingly, might it just travel in a straight line right towards our target? Frankly, I really don't know, but there's only one way to find out.
We've set up our mock World War II battlefield, complete with anti-tank Czech hedgehogs, tangles of barbed wire, and our representation of the Nazis' Atlantic seawall.
Here's what's gonna happen. I'm gonna head down there to that spool. Crew's gonna get to a safe position, and on the radio, I'm gonna count down 3, 2, 1, and push this beautiful shiny red button. When I do, a relay will shunt power from a car battery to 32 rocket igniters. An initial half-second force of 300 pounds will start our Panjandrum going. And for the next 15 seconds, 100 pounds of force will keep it rolling, hopefully all the way through our target. And then there'll be some cheering. Or, if anything goes not according to plan, I've got a big green tractor to hide behind. All right, let's go. Launch box is plugged in. Arming the box. We are armed. Firing the Panjandrum.